To demonstrate additive synthesis, I'm going to use my personal favorite additive synthesizer, Loom by Air Music Technology. Loom is a software additive synthesizer with some pretty innovative features to help demystify additive synthesis. Loom is set up in a modular fashion with 10 spaces to place any module. The first thing to mention is that Loom only contains two windows, Edit and Morph. The Edit window is where we create and adjust our sound, while the Morph window gives us some performance control as well as a really cool morph screen with which we can automate various parameters of the synthesizer. Also in the morph screen is a graph which gives us a real-time display of the frequencies and amplitudes of our partials. Going into the edit mode, there's a few things we need to familiarize ourselves with. First is the partial section. Using the drop-down menu, we can select how many partials we'll allow per voice at any given time. The more partials we select, the richer our sound will ultimately be. However, more partials take up more CPU power, so keep that in mind. Next to the per voice tab is a current tab, which tells us how many partials are being used at any given point when a note is played. Next, the sync button designates whether all partials will be synced and start at the exact same time when a note is pressed. Typically this is left on, but by turning it off we can get some interesting results. Below the partial section is the individual module spaces. Like I said, there's 10 spaces which each can be loaded with any module. There's a few different categories of modules. Basic modules act as our main building blocks of additive synthesis, with modules to designate the odd and even harmonic relationships, octave and organ simulation modules, and a few musically designed modules to add higher order harmonics. Next are a series of modules which aren't always additive in nature but can help us further sculpt our sound. A good example of this are the filtering modules. Although filtering is not an additive synthesis technique, allowing the use of a low-pass filter helps us quickly get a desired sound. So let's start creating our sound. As you can see, Loom defaults by placing an odd and even module in the first space and a gain module in the last place. The odd and even module allows us to determine whether our sound consists solely of odd harmonics, even harmonics, or any combination in between. If we rotate the odd-even knob to the left, we begin to only hear odd harmonics, while rotating it to the right will yield only even harmonics. The damping control determines how much amplitude will be given to the higher order harmonics. Finally, the fundamental control determines the amplitude of the fundamental frequency. We can modulate any of these parameters by choosing a modulation source in their corresponding drop-down menus. Next, let's add in a second tone module. This module raises the amplitudes of various higher order harmonics to place a larger emphasis on another frequency. We can raise the amplitude of the added second tone as well as adjust the damping and detune amount. Next, let's add a rhythmic module to the mix. Let's select the random drops module. This effectively raises the amplitude of random harmonics in our sound at set rhythms which can be synced to our project. We can control the depth at which these random harmonics are heard as well as the rate and length of the drops. The thing to remember about Loom is that it's modular in nature. This means that when placing a module, it will affect only the sound which comes before it. So let's explore that and add a resonant low-pass filter before the second tone and random drop modules. To do this, we must move these two modules further down the line. As you can see, the low-pass filter is now only affecting the odd and even module. By default, the low-pass filter is being modulated by envelope 2. Now let's add a sync module into the mix. The sync module acts like a hard sync on a subtractive synthesizer. So by adjusting the frequency control, we can do that familiar sync sweep. Let's modulate the frequency control with envelope 3. Now we can dial in the sweep that we want. Finally, I'm going to move the gain module earlier in the chain and add a repeater module after it. The repeater module acts as a delay. It's also worth mentioning that Loom features a smart random control. By clicking the random button, the modules will change. You can also shift-click the random button, which will only change the module values rather than the modules themselves. Even with just this brief outline, you can see the sonic potential of this synthesizer. Let's end this video with an exploration of some of the onboard presets to give you a deeper understanding of what Loom has to offer.